Welcome to my YouTube channel Reagents, and today we will see in the organic chemistry that what and all are the important reagents and what and all are the products from these reagents. Okay, so in the organic chemistry topic we will see today important reagents. Okay, so first our reagent is LiAlH4, lithium aluminium hydride. Okay, so it is an important reagent and in various reactions it is used. Okay, so in this lithium aluminium hydride, so if any ketone is there, suppose that R1 COR2 is there in a particular reaction, and it is asked that with the help of LiAlH4 we are reducing, so it is a reducing agent. LiAlH4 is a reducing agent. Okay, so what is the product from this? So the product will be RCOH R2. Okay, R1, so a 2-degree alcohol will be formed, okay, from this, okay, by reducing with LiAlH4. Okay, so suppose that in the place of this ketone, see this is a ketone, the ketone to 2-degree alcohol will be there if LiAlH4 is present, okay, as a reagent. Okay, if in place of this ketone, suppose that aldehyde is there, R1CHO, so this is an aldehyde. Okay, so if aldehyde is there and LiAlH4 we are reducing with the help of LiAlH4, so a 1-degree alcohol will be formed, or R1CH2OH. okay, so this is a 1-degree alcohol. Okay, so how these types of alcohol are defined? 2-degree alcohol. What is a 2-degree alcohol? In the 2-degree alcohol, this R1 and R2 will be present and this OH will be there. Okay, and in the 1-degree alcohol, R1 CH2OH will be there in a 1-degree alcohol. Okay, so from a ketone to LiAlH4 as a reducing agent, a 2-degree alcohol, and aldehyde with the help of LiAlH4, 1-degree alcohol will be formed. Okay, so these are the two things which we have to remember. Okay, so suppose that if C triple bond N is there, okay, C triple bond N is there and we are reducing with help of LiAlH4, so it will form CH2N2. Okay, so suppose that there is a reaction CH3 CH2 C triple bond N and reagent is LiAlH4. Okay, so we have to find the product. What will be the product of this reaction? Okay, so we have to tell what is the product. So what will be the product? CH3 CH2 CH2N2. so this will be the product from this reaction. Okay, so this is the product. So suppose that there is a reaction in which it is there that CH3 CH2 C double bond C CH3. Okay, so CH. Okay, so and LiAlH4 is there as a reducing agent. So what will be the product? We have to find what will be the product. So it will not reduce this alkene. Okay, so LiAlH4 does not reduce alkene, so product will be same. Okay, because it does not reduce alkene. Okay, so it is the property of this lithium aluminium hydride. That it does not reduce the alkene. Okay, so it also does not reduce the nitroamine and the amide amine. Okay, also it does not reduce. Okay, so these were the properties of the lithium aluminum hydride, or the LiAlH4, that ketone to 2 degree alcohol, aldehyde to 1 degree alcohol, C triple bond N to CH2N2, CH2NH2, okay, and does not reduce alkene or nitroamine and amide amine. Okay, so these are the properties of the lithium aluminum hydride. So whenever any question is there and it is asked, so we can tell easily. Okay, so these were some of the properties from the lithium aluminum hydride. Okay, so now we will see a next reagent, which is NaBH4. Okay, so we will see in the organic chemistry, whenever this NaBH4 is there, so what and all are the products from the reaction. Okay, so this is a very important reagent, NaBH4. So whenever it is there, so what and all are the products from the reaction. So the first this the property of this NaBH4, or the what will be the product when NaBH4 is there. So if suppose that there is a presence of this CO group, okay, or the ketone group is there, so it does not reduce to 2 degree alcohol. So as lithium aluminum hydride was reducing, but it does not reduce to 2 degree alcohol, and it also does not reduce this aldehyde to 1 degree alcohol. Okay, so as LiAlH4 was reducing, but NaBH4 will not reduce. Okay, and it also not reduce this COCl2 CH2OH. Okay, so these are the properties that if it is there NaBH4, this aldehyde will not be reduced to 1 degree alcohol, ketone to 2 degree alcohol, and COCl2 CH2OH. Okay, so suppose that, so there is a reaction, the CHO CH2 CH2 CO CH2 COCl. Okay, so this is the reactant. Okay, and NaBH4 is present, and we have to tell what is the product of this reaction. Okay, so as it does not reduce this, so no change here. As it does not reduce this ketone, so no change here, and also no change here as it does not reduce also this. Okay, so product will be same as reactant. Okay, so no change will be there, as it does not reduce any of these. Okay, and it also does not reduces any other acid derivative. Okay, so these were some of the properties of the NaBH4. Okay, so let's see some of the other properties of the other reagents. Okay, so now we will take the next reagent is ZnHG and concentrated HCl. Okay, so our third reagent is ZnHG concentrated HCl. Okay, so when this reagent is present, what will be the products for the reactant? Okay, so first property of this is, suppose that a phenol group is present. Okay, suppose that this phenol is there. Okay, and ZnHG concentrated HCl we are using, so the product will be same as this reactant. So no effect is there when ZnHG concentrated HCl is there, okay, on this phenol group. So these are some of the important points which we have to remember. Okay, so in the if the ZnHg concentrated HCl, so if it is there an alkene, okay, so suppose that there is an alkene CH3 CH2 CH double bond CH CH3, okay, so suppose that there is a presence of an alkene, so alkene is affected by this ZnHg concentrated HCl, okay. So these are the some of the properties of this ZnHg concentrated HCl, okay. So suppose that, but in this same alkene only, but this is like this CH2 CH double bond CH CH, this single bond CH double bond CH, okay, and this CH3, okay. So in this, what is there, this alkene is in conjugation, okay. Suppose that this is like this C double bond C double single bond C single bond double bond C, okay, C, okay. So if it is in conjugation, okay, so then it is not affected. So this is an important point in the ZnHg concentrated HCl. We have to remember that if alkene is affected, okay, but if it is in conjugation, so not affected. So this is the property which we have to remember, that if the alkene is in the conjugation, it is not affected, but if it is not in conjugation, it is affected and reduced, okay. So this is the property for this. So let's see what will happen if ketone is there, okay. So if ketone is present, what is there, okay, so it reduces this ketone CO2 CH2, okay. So suppose that there is a ketone CH3 C double bond O CH2 CH3. If this is there, so what will be the answer? So answer will be CH3 CH2 CH2 CH3. It will form an alkane, it will reduce this, okay. So if CO is there, ketone is there, it will reduce to CH2, okay, CO2 CH2 with the help of ZnHg concentrated HCl, okay. So this is the property of this ZnHg concentrated HCl, that ketone to CH2 it will reduce, okay. And suppose that this C double OH is there in the particular alkene or alkyne, okay. So suppose that there is a reaction CH3 CH2 CH2 C double OH, okay. What will be the product of this reaction if ZnHg concentrated HCl we are using, okay. So if ZnHg concentrated HCl we are using, and this is the reactant, so and this is the reagent which we are using, so not effect on reactant, okay. Since this is also acid, so no effect it will be there on this CH2H. Product will be same as reactant, so it will be like this, okay. Since COOH also is an acid, so no effect will be there with the help if we are using ZnHg concentrated HCl. So product will be same as that of the reactant, okay. So suppose that there is a presence of this OH group, okay. So phenol, as we saw that this phenol was not affected, this if this is there, phenol was not affected, no effect. But if OH is there, which is like this, since it is in conjugation, we can see in the alkene also, if it is in conjugation, no effect. Suppose that there is an alcohol which is like this CH3 COH CHOH CH2 CH3. So what will be the ZnHg concentrated HCl we are using? So what is the product? So product will be CH3 CHCl CH2 CH3. So OH is converted to Cl. Okay, so if OH is present, so it will be converted to Cl. If the 1 degree alcohol, 2 degree alcohol, 3 degree alcohol, any alcohol is there, so it is converted to Cl. Okay, so suppose that CH3 CH2 OH, so it will be converted to CH3 CH2 Cl, CH3 CHOH CH3, so CH3 CHCl CH3. Okay, so CH3 C CH3 CH3 OH, so CH3 C Cl CH3 CH3. So these are some of the reactions for the ZnHg concentrated HCl if we are using. Okay, so these are some of the properties which we have to remember, that from the reaction with the alcohols it will be forming the from with the place of OH Cl will be added. Okay, so now we will see what will happen if the reaction with per acid is there. Okay, so if per acid reaction with per acid is there, so anti addition of OH group will take place. Okay, so per acid is there if any inorganic compound. Okay, and ZnHg concentrated HCl we are using. Okay, so anti addition of OH group. Okay, so if one OH group is adding like this, so another OH group will be added like this, so anti addition. Okay, so 2 OH will be added to organic compound in anti manner. Okay, so one OH group will be added like this, another value like this. Okay, in a trans manner you can say that. Okay, so these were the some of the properties for this ZnHg concentrated HCl. Okay, so the three reagents we see: LiAlH4 we saw, NaBH4 properties, and ZnHg concentrated HCl. Okay, these were the three reagents which are the important in organic chemistry. So various answers of the reactions you can give while learning these properties of these LiAlH4, NaBH4 and ZnHg concentrated HCl. Okay, thank you.